Now let's look at the stairs. So, yung stairs, meron siyang horizontal dimension na 4 meters, tapos may height na 3.2 meters. And then, ito yung beam. This is at grid A prime, which is ito. Ito yung 2.5 meters. Ito yung harapan. And ito yung harapan. Okay? So, this part, ito yung frontage ng building. So, let's look at the stair loading. First is computein natin yung railing, ano? The railing is equal to the length 5.12 multiplied by 2.98 multiplied by 1 meter multiplied by cosine theta. Ang cosine theta is adjacent all over hypotenuse. Now let's look at the geometry. Yung cosine theta or yung angle is somewhere here. So, ang adjacent mo yung 4, tapos yung hypotenuse is the 5.12. Okay? Kinuha natin yung cosine theta dahil yung load is acting downwards, tapos yung applyan natin ng load is again inclined. Okay? So cosine theta. So going back here, we will multiply this by cosine theta, which is the adjacent 4 divided by the hypotenuse na 5.12. Ayan. So, meron na tayong concentrated load, which is 11.92 kilonewtons. Now, yung 11.92 kilonewtons is the concentrated load of the railing of the entire stairs. Take note na ang railing na ilalagay natin dito is hollow blocks na 1 meter ang height. Pero in reality, hindi tayo maglalagay ng hollow blocks na railing dyan. Pwedeng tubo o kaya kahoy na railings. And yung railings na yon, ang bubuhat doon is yung beam dito sa A prime saka yung beam dito sa grid B dito. Okay? So hahatiin natin yung railing into 2 to be carried by the beam at A prime and the beam at B. Okay? Sa taas. And concentrated load yan. So, going back here, we have to divide this by 2. And multiply that by negative para maging downward force. Okay, so yan yung negative 5.96, which is this. Next is ang application ng load niyan. Going back to the geometry, this is at grid A prime, which is this, sa gitna, yan. So, ito yon. Dito natin i-apply sa gitna. Concentrated load yan, hindi yan nodal load. Next is yung sa second floor naman, dito natin siya i-apply. Okay? Diyan. So, going back again to stair slab naman. Yung stair height, that is 3.2. The stair horizontal length is 4. The slab thickness is 5 inches or 125 mm. And then you have the tread of 0.28 meter. Riser height na 0.23. The number of steps is 14. This is your actual riser, and then the stair length. Tapos, yung floor finish 1.18. And then the ceiling is 0, stair steps 2.06. Lahat yan, na-cover na natin to dun sa stairs. Okay? Which boils down to negative 15.86. Ngayon, saan galing itong 15.86 na yan? That is the stair length. Okay? Multiplied by the dead loads and then divided by 2. Okay, so let's try that. Stair length times the dead loads, total dead loads divided by 2. Ayan, 15.86. Gawin mo siyang negative. And itong dead loads na yan, take note that this is the sum of the super dead loads tsaka yung self-weight. Okay? Yan. And then, i-apply natin ito as member load na uniform force but it is partial. Dahil, if you will look at the geometry sa first floor, yung stair loads, yung stair slab, nakapatong lang yan sa kalahati ng grid A' or kalahati nito. Okay? Siyempre, dito sa kabila, walang stairs dyan. Pero pagdating mo sa second floor, take note na yung kalahati nitong stairs going up is this one. Tapos meron ka na namang kalahati going up, which is this. And you'll notice na parehas silang 3.2, parehas din silang 4 meters ang horizontal length. So basically, uniform load siya over the entire length of the second floor beam. Yan. Okay, so now let us load the stairs. Before loading the stairs, i-edit muna natin yung ating command file. Okay, so dito sa floor loads, then this is floor loads. Okay, ganyan lang. Parang inulit mo lang yung command niya. Floor loads, tapos second to third floor loads. Okay na yan. Okay. Save. And then we now select the first floor. Tapos, ito yung grid A'. Okay, remember that. Balik tayo sa definitions, dito sa reference load, and then R1, and then add. Punta tayo sa member load. Okay, and then concentrated force tayo. Take note na kilonewton ang kanyang unit, which is, ayan. So, negative 5.96. Tapos, ang distance natin, that is the distance from the start node, ano? So, this is 4.5 divided by 2. Kaya, ang ating D1 would be 2.25. So, that means sa midpoint ng beam. And then, we now click add. Make sure na naka-global Y ka. And then, yung uniform load, mamaya na yan. So, first, we apply this load. Okay, click mo yan. And then, use cursor to assign, and then i-click mo ito. See? Yan yung railing load natin. Take note na hindi siya nodal load, okay? Concentrated force yan. Kapag nodal load yan, syempre sa node siya mag-apply. Next, we now apply the slab. Ito, yung stair slab. So we click add again here. And then that is member load. Okay, uniform force tayo. Uniform force with a distance of 2.25 up to 4.5. Ngayon, yung D1, yan yung point nung start no partial load. Tapos yung D2, yan yung end point ng partial load. Yung W1, okay? Yan ang loloadan natin. Okay, so yung D1, i-apply natin yan sa gitna. Tapos yung D2, hanggang dito sa dulo ng beam. So, our W1 would be negative 15.56. Tapos, ang D1 natin would be 2.25, and then D2 is 4.5. Then add, close. We now apply this or assign it here. Yan, yun. See? Yang load na yan, yan ang stair slab natin. Next, punta na tayo sa ating utilities. Command file. I-edit na natin yan. So, member load, dyan, dalawang line. Stair loads. Okay. And then, this is negative 5.96. That is railing at 1F. Okay. Railing at 1F. Tapos, itong negative 15.56, ito yung stair slab. And that is, let's say, stair slab 1F going up. Okay? Yan. So, ibig sabihin, yung mula sa first floor, kalahati nun going up. Yan yung negative 15.56. Okay, next. So, we save this. We now go to the second floor. So, view. Dito tayo sa second floor. Selected objects only, and then isometry. Okay. Dito tayo ngayon sa stair loads at second floor. Notice na sa second floor, okay, dito, dalawa ang railing natin. Merong going down, tsaka merong going up. And parehas lang sila ng length, 5.12 tsaka 5.12. So that is simply negative 5.96 times 2. Okay. Ayan. So this is the same as, parehas lang yan, negative 5.96 times 2. 11.92. Or, inulit ko siya. Okay? Ang ginawa ko, stair length times 2.98 times 1 times cosine theta again, 4 divided by 5.12, then divided by 2. Okay? So, that is, remember that that is negative. And then, i-add lang natin yung nasa baba. Okay? So, parehas lang yan. 11.92. Next, yung stair slab, remember na meron siyang up and down. Stair slab at second floor, going up tsaka going down. Ito siya, going up, kalahati, and then kalahati nung going down. So, parehas lang silang na negative 15.86. Ayan. 15.86. Ngayon, yung kalahati, 15.86. if you will look at the geometry, ito yung down, ito yung papunta sa first floor, tapos ito yung up, papunta naman sa third floor. Parehas lang silang 15.96. So, we simply now add loads. So, definitions, reference, add, here and then add member load, concentrated force, yung railing muna. So that is negative 11.92. Again, that is concentrated force at mid-span, so 2.25, then add. Tapos, maglagay tayo ng uniform force na negative 15.86. Okay? So, walang D1, walang D2 ngayon. That means over the entire length of the beam. Then, add again. Okay, so we apply this. Pressure to assign. Dyan. Yan. Tapos, ito, 15.96. We assign it here. Okay? Tapos, i-edit ulit natin siya sa command file. Okay? So, mapapansin nyo, this is series 1000, tapos series 2000 na beams. So, that means second floor. And this is railing at 2F. Tapos, this is stair slab. Okay? 1F going down. Tsaka 2F going up. Yan. Okay? Then, save na natin. Okay, so na-save siya. Next is at third floor naman na. So, yung railing mo, it is going down negative 5.96, tapos 15.86 pa rin. So, select natin yung third floor. And this time, merong node sa gitna. So, hindi na siya concentrated force. It is now nodal load. Okay? So, si 15.86, uniform force. Si railing load, nodal load na siya. Okay? So, let's add. Nodal load. Fy negative 5.96, then add, tapos member load negative 15.86, and then add. Always check na naka global Y siya, then add. Then we will now assign this nodal load here. Yan. Okay, look at this. This is grid A prime at third floor. Yun. See? Ito yung third floor. Remember, ito yung third floor. Yan. Okay, third floor. Dito yung railing, which is this. Tapos dito natin i-apply yung stair slab. Yan yung going down sa second floor. Which is at this part. Okay? So, i-click natin ito. And then, use cursor to assign. And then, click here. Okay guys, so i-edit ulit natin yung ating editor. Command file. Tapos, dito sa series 3000, then this is railing at 3F. Tapos, this is stair slab. Ito ay magiging 3F going down. Okay. Then save. Okay. Tapos dito na tayo ngayon sa roof loads. Yang 11.96. Save ko muna. Kinuha natin yan sa ating project na truss. Pakita ko lang. So, open. Truss 1. I think ito yun. Okay, so try ko ito, truss 1. Okay. And then, check ko sa utilities kung meron siyang analysis output. Okay, so pag meron siyang analysis output, ibig sabihin, na-record pa niya yung kanyang run analysis. So, probably meron pa siyang post-processing. So, okay mo lang yan. And then, kukunin natin yung reactions. So, dito tayo sa post-processing and then reactions. Click mo lang ngayon yung DL, dead load. Tapos, i-click natin yung letter A. I think nandito yun sa view. Hindi ko na makita kung nasan yung move text na yan. Anyway, this support is 11.969. Ayun. This is, remember that this is grid A. Okay, let's look at the geometry sa roof beams. Yan. So, this is grid A. Tapos, ito naman, grid B. And then, yung dulo, ito, that is grid C. Okay, so, A is 11.969, grid B, 11.298, and then grid C, 6.615. Yan yun. Tapos, yung exterior truss reactions naman, ang assumption ko dito kalahati lang. If you will look at the geometry, okay, so, meron tayong truss dito. Yan. And then, yung truss natin meron din sa gitna. Remember na ang truss natin is at every 2.25 meters. Tapos meron din tayong truss dito. Okay? So, ang tributary length nitong mga trusses na yan would be this. Yan. Okay, so shape fill is none. Okay, tapos same thing, ang tributary area nitong truss na yan, itong kabila, would be yan. Pero, etong truss sa dulo, ang kanyang tributary area or the area na sinusuportahan niya is obviously kalahati lang. Yan lang. So in short, yung reactions na ilalagay natin dito, kalahati din. Okay, so at exterior trusses, kalahati ang kukunin natin dito. So 11.96 divided by 2, 5.985. Ayan yun. Likewise, for grid B, half of 11.298 will give you negative 5.649 and 3.208. Next is, dito na tayo ngayon sa firewall. Okay, dito sa geometry, tanggalin ko na yan. At this part of the beam, wala nang lumampas dyan na purlins, kaya firewall na yan. Okay, so that is CHB na 4 inches pero plastered on one face only. And then ang height nito, okay, take note, would be let's say ito 0.604, tapos yung height ng hollow blocks dito sa gitna would be yan 2.2. Okay, so remember those numbers. Tapos remember that this is 7 and the distance from the support going here at the midspan is 4.75. Okay, so tanggalin ko na muna yan reactions na yan. Tapos from the center going to grid B, that is 2.25. And then yung height nito is 1.44. So remember those numbers. Okay, so ang una nating loloadan would be yung 2.5 meter firewall, which is ito. Okay, so node 2, ito yung 2.5 meter na firewall. So ang height na i-consider natin dyan, since this is trapezoidal load, would be 0.6 tsaka ito, this is 1.44. Okay, next. Ang sabi ko kanina, 0.6 tsaka 1.44. Pero ang ginamit kong height dito is 0.893. Bakit kaya 0.893? Dahil yung hollow blocks ko, nilampasan ko yan. Okay? Ibig sabihin, yung hollow blocks, mas mataas siya kaysa sa yero. Okay, so it makes sense, right? Now, i-check ko kung ilan ang itinas ko. 0.893 minus 0.6. Ayan, 0.293, or that is almost 1 foot. Okay, so check natin dito. 0.245. Yan. So let's say, ang gagamitin ko dito na height is 0.6 plus 0.3. And then dito naman, that is 1.44 plus 0.3. Okay na yan. Yung 1.44, take note na galing yan dito sa 2.2. Okay? Sorry, dito pala. So 1.44 plus 0.3. Next, let us now compute yung trapezoidal load would be based from roof firewall, which is 4 inches CHP plastered one face only. Ito yon. So that is 2.5 plus 0.24. Dati-rati, dalawa yung 0.24 na yan. Ano? So this value would be equal to 2.74 times the height na 0.9. Next, ito naman, 2.74 times the height na 1.74. Yan ang gagamitin natin na trapezoidal load. Okay, we will apply that trapezoidal load over this 2.5 meter beam. Next, so i-apply natin yan. So going back to our stud, wait. Drawing ko lang. Okay? Yan siya. Dati-rati, uniform load, pero ngayon gagamit na tayo ng trapezoidal load. Ito yung trapezoidal load, i-apply natin yan dito sa 2.5 meter beam. So, itong load na yan, yan yung 2.466. Dito sa dulo, yan yung 4.766. Next is, ang applyan naman natin ngayon is the 4.75 meter part of the 7 meter firewall. Notice na from this point up to this point, yan ay 7 meters. Isang beam lang yan. So mag-apply tayo ng dalawang trapezoidal load, which is the 4.75 tsaka yung 2.25 na trapezoidal load. Okay? So, i-drawing ko lang. Yan. Okay. So, unahin natin itong 4.75 meter na part nung 7 meter wall. Remember that the 7 meter wall is composed of these two trapezoidal loads. Okay? First is establish natin yung mga heights. So, this is 0.6 plus 0.3. Okay? So, that is equal to 0.6 plus 0.3. Next, height naman dito, this is 2.2. Okay? So, the height is 2.2 plus 0.3 ulit. Yan, 2.5. And then, for the 2.25 meter part of firewall, eto na yun. Yung height, again, is equal to 2.2 plus 0.3. And then, this height is 1.44 plus 0.3. 1.44 plus 0.3. Yan. Next is, we will now multiply them with the 2.74. Okay? So, this is equal to 0.9 times 2.74. Tapos, ito naman, 2.5 times 2.74. Ganon din dito. And then, ito naman, this is also 2.5 times 2.74. Okay? So, ganyan yun. Next. Etong 4.75 meter part is this block. Okay? So, yung 2.466, ito yun. Tapos yung 6.85, ito yun at this end. Next. Yung 2.25 meter part, ito siya, which is this. yung height na yan corresponds to 4.768 and then this height corresponds to negative 6.85. Take note na parehas silang 6.85. Ayan. Okay, so in short, ma-imagine mo ngayon na ito yung firewall composed of hollow blocks. So balik na tayo ngayon sa ating frame. Okay, so click natin yung dalawa. Oops. Baba muna natin yan. Click na natin yung buong roof beam. So view, let's just select the roof beam. Tapos, maglalagay na tayo ngayon ng loads. Remember na ang loads natin ay nodal loads tsaka concentrated forces. So, balik tayo sa loading. And then, sa definitions. Sa ref load pa rin tayo. Then, add. So, unahin natin yung interior truss reactions na nodal load and member load. Okay, so nodal load, that is negative 11.969. Add. Tapos, negative 11.298. Add, and then negative 6.615, then add. So that is the nodal loads. Ngayon, punta tayo sa member load. I-apply natin to sa gitna ng beam, which is at distance na 2.25. Ayan, 2.25. So first, we have the negative 11.969 with a D1 of 2.5. Then, look at this GY once in a while. Ano? Add. Tapos, negative 11.298. Add again. And then, negative 6.615. Then, add again. Okay, so wag muna nating ilalagay yung exterior truss reactions. Interior truss reactions muna tayo. So, sa interior truss reactions, meron tayong nodal loads tsaka beam loads. Okay? So, click natin ito. Then, assign, use cursor to assign. Notice that this is nodal loads. Okay? So, this is at grid A and this is grid A, okay? Yan yung nasa likod. Ito, okay? Tapos, nodal loads, dito natin yan ilalagay. Click, and then click. And then, yung 11.298 nasa grid B. Okay, so we will use cursor to assign again. Grid B, ito siya. Tapos, ito 6.615 nasa grid C. Nasaan si grid C? Ito siya, which is at these points. Yan. Or this. Next is, dito na tayo sa member concentrated force. So, i-click natin ulit si assign. Dito natin siya ilalagay. Oh! Mali. Mali. So, escape. I-edit. I-delete natin yan. Yung tatlong yan. Then, add ulit tayo. So, saan ako nagkamali? Member load, concentrated force. Ayun, dito ako nagkamali. And that is negative 11.969. B1 na 2.5. Add. Tapos, negative 11.298. Then, add. And finally, negative 6.615, and then add again. Then let's close. Now let's apply. This is at grid A. Okay, so dyan. Yan. Then this is at grid B. Tapos, i-click mo yan. Assign ulit. This is at grid C. Okay. Is this really 2.25? Pero pag i-click ko ito, look at my figure. Parang hindi siya nakagitna, di ba? So, to edit that, you just double click. Then, edit mo ito, 2.25. Modify. Or, ayun, nag-edit siya, no? Pwede mo i-edit yan dito sa utilities command file. Yan, dito mo na ilagay 2.25 tapos 2.25. Yan yung D1. Okay? Tapos, ito yung loads. At the same time, mag-edit na rin tayo. So, ito yung this is the nodal loads at grid A. Okay? Tapos, maglagay ka dito ng truss loads. Okay? Tapos, ito naman, this is nodal loads grid B. And then this is nodal loads at grid C. And then ito naman, this is again under truss loads pa rin ito. Ito naman ay member loads at grid B. So pwede ko nang tanggalin yung member loads. Grid B, sabihin ko na lang. Tapos dito, oh no, this is grid A. Then this is grid B. Finally, this is grid C. Okay. And then, since meron tayong joint load dyan, pwede mo nang tanggalin yung nodal load. Okay lang. Dito, member load, merong member doon, tinanggal ko na yun. So, I might as well remove this word nodal. Okay. Next is, we now save. And then, i-click natin. Yan. See? So that is nodal load grid B, nodal load grid C, member load grid A, member load B, member load at C. That's it. Now, we are going to load the firewall. So select natin ulit yung ating roof beams. Okay? Ang una nating ilo-load would be the 2.5 meter firewall, which is this. So the command there is add then member load, hanap ka dito ng trapezoidal. Okay, or linear varying. Yan, mas maganda na yung linear varying ang gagamitin natin kasi dito wala nang D1, D2. Automatic ends yun. So, ang gagamitin natin, negative 2.466. Tapos, negative 4.768. Then, local y and then add. Then, close. Testingin natin. And use cursor to assign. Ito yung 2.5 meter. Ano? So, i-apply natin dito. Okay. Look, baliktad ang kanyang orientation. So, double click lang natin yan. Baliktarin natin to na yan ang magiging negative 4.768. Tapos, ito naman yung negative 2.466. Then, modify. Okay. Next, we now load the 7 meter firewall. Ito yun. Okay? 7 meter. So, nawala yung loading dito. You just click geometry and then back to loading. Tapos, click mo ulit yan. And then, dito. Now, add sa member load. This time, let us choose trapezoidal. Okay, so meron na tayong D1 at D2. So, D1, that is the starting point. D2, that is the end point of your trapezoidal load. So, ang gagamitin naman natin ngayon na W1 is 6.85. Okay, negative 6.85. Ang D1 is 0. Tapos, ito naman, negative 2.466. Ang dito natin ay 4.75. Next, so what are we loading? It is this part, okay? Yung part na yan. And ang ating D1 corresponds to this part. Okay? Tapos yung D2, 4.75. Okay, let's check. Close. And tingnan natin. Then, use cursor to assign. Yun, see? Baliktad na naman. So, let's double click. This now becomes negative 2.466. Tapos, this becomes negative 6.85. Okay? Yung D1 na yan always starts from the start node. Yung dito ganun din is measured from the start node again. Okay? So, let's modify. Dapat okay na yan. Then, click mo. Yan. See? Next, we will now load this part. So, ang magiging D1 natin ngayon would be 4.75 dahil dito na tayo maglo-load. Tapos, ang dito sa end ng beam which is 7 meters. Okay, so back to reference load, add, and then member load, trapezoidal. Ang ating W1 would be negative 6.85. Ang ating D1 is 4.75. Tapos ang ating W2 negative 4.768. Our D2 is 7 meters. Then add and then close. Next, we will now assign at this part. Yan. Tsaka dito. Okay? So, yan ang ating firewall. So, I will just click once here. Yan. tapos ito, then yun, which corresponds to these 3 loads. Next is what is a rigid diaphragm. Ang purpose ng rigid diaphragm is yung loads sa bawat floor, i-transmit niya sa i-distribute niya, no? Likewise, yung displacement at this point would be the same as the displacement at the other point. So, something like that. In short, parang the entire floor, yung slab, is acting as a diaphragm. Okay? Parang stiffener siya. Okay? Kasi may slab. Obviously, stiffener, pangpatigas. Next. So, select natin view. Then, display whole structure. Siyempre, ang slab dito ay nasa second floor tsaka sa third floor. And obviously, meron ka ring slab dito sa first floor. Okay? So, you will notice na ang diaphragm natin, tatlo. Which is defined by number 1, first diaphragm, ito. It is at a distance of 1.5 meters from the ground. Tapos, itong second diaphragm natin, it is measured at a distance of 4.7. Paano malalaman yung distances na yan? So, punta ka sa utilities. Then, node tools. Pwede mong i-click yung node to node distance. Okay. 7.9. Yan. Sa taas. 11.1. Dito naman. 4.7. Tapos ito 1.5. Okay. So you have here 1.5, 4.7, tsaka 7.9. Otherwise, you just select your node cursor, double click mo yung isang node, lalabas yung Y coordinate, which is 7.9. Okay? Ganun din dito, click mo yan, lalabas yung Y coordinate na 4.7. And yung Z coordinate, that is obviously at elevation 0. Okay, to do that, lahat ng slab is acting as diaphragm. So we go to first, you have to select the nodes. So select natin yan. Oops. Tanggalin muna natin si measurements. So remove node to node distance. Ayan. And then select node cursor. We first select the nodes. Ayan. Tapos, punta tayo sa specification. Ito. And then, you click node. And then, you click floor diaphragm. Tapos, yung number 1. Then the height is 1.5. Okay? And then i-uncheck mo ito. Kasi meron naman na tayong height dito. Then you click assign. Okay? Next, click ulit natin tong node. Oops, escape tayo. This time, wala tayong wala tayong sinelect na node, but we will just assign anyway. Floor diaphragm. and then diaphragm is 2, height is 4.7, and then you click add. Then i-click natin itong first. Ang ibig sabihin yan is diaphragm, type is rigid, and then the height is 1.5. So you click highlight assigned geometry. Yun no. Tapos i-click natin to, and then make sure na naka-check yung assigned geometry. Yun, nag-a-assign siya. So pwede pa lang hindi ka na mag-select, di ba? So meaning lahat ng nodes at that height isa-select niya as part of your rigid diaphragm. So display whole structure, and then click natin to. Ayun, nag-highlight siya. Pwede mong i-rotate vertically. Yan. See? Makikita mo ngayon. Then, second diaphragm, ayun siya. Tapos, node again. Floor diaphragm. The third is with a height of 7.9. Then, i-uncheck mo yan. You just click, wag mo nang i-click yung assign. Otherwise, pati yan, lalagyan niya. So, you just click add. Okay? Yun, see? Ngayon, i-click, let's click outside here to unselect. Click natin tong si first diaphragm. Ayan. Tapos second diaphragm. Ayan. Then finally, the third diaphragm. So, that's how to check your rigid diaphragm. Next is, dito na tayo sa seismic definitions. Okay. So this is now part of earthquake engineering. Okay. So we are done with loads, dead loads actually, tapos yung rigid diaphragm. I-edit muna natin yung mga remarks. Okay, sa utilities. Yan. This is now your wall loads. Okay. And then this is your diaphragm loads. Then save. Ngayon, ayusin natin itong seismic definitions. Remember that sa parameters, seismic parameters, yung ating location ay 12 kilometers from the nearest fault line.